Alright, welcome to Algebra 2, Module 3, Unit 8, Lesson 2, Scientific Notation. You should know this from years past. So, we're going to look back at the last lesson, and this one's about a thickness of a gold sheet of foil being folded up. But they basically just want us to convert 0.28 millionth of a meter to centimeters, okay, and express as a decimal. So you know you got 0.28 millionths, so you put it over a million. And of course that's meters. Then they want us to convert it to centimeters. Well, how many centimeters in a meter? So times 100 centimeters in 1 meter. So if you cross multiply, bottom line here is the meters. You cross multiply, doing this, the meter in the top here, it cancels with the meter in the bottom. We get rid of it. And now we've got centimeters now. And I turn around and I multiply the tops. So 100 times 0.28 is straight out 28 over a million. And so you get 28 over a millionth centimeters. And if I have 28 millionths, you take the 28 millionths, dividing by that, 6 zeros in there. So move the decimal 6 spots from where it is right now. 2, 3, 4, 6, and your answer is 0.000028 converted. Alright, that's how you do that one. Now in this part here, I want you to pause the video. I want you to match up these things. Let's see if you remembered. If not, go on to the next part, and you can always come back to this. Pause for a sec. So, I got 3.5 with 10 to the 5th. That means move the decimal from the 3.5, 5 to the right, so that's going to be 3.5, becomes 35 and 4 zeros, so that one goes with that one. Okay, so negative 6 is just negative 6, so it's times, basically move it over here, times 10 to the zeros, times 1, so these two match up right there. Okay, and then what else do we got here? Well, we know this has got to go 1, 2, 3, 4, 5, and then 1 there, so that's 10 to the negative 6. So those two match up. And 0.6 itself is really 10 to the negative 1, because you got to go 1 spot to the left and made it smaller, so that one matches with that one. Back to red. And this one's got 5 zeros in it, plus a space, so that's 6 total spaces. So those two go together. So those are your matches as far as scientific notation goes. Now removing the decimal, if it's positive, you move to the right, and negative go to the left. You got to counter it when you rewrite it. So we're going to go back and review. Basically, in this example 1, it says write each as a product of a decimal between 1 and 10 and a power of 10. So all they're asking you for is straight out scientific notation. So my decimal is here. You got to move it 1, 2, 3, 4, 5. Just made that smaller, so it's now 2.34 and times 10. And now by making it smaller, this has to actually make it bigger. You got to do the positive. So I move that thing smaller. The times 10 has to go the opposite way, positive. Same thing. Or remember the rule: if the thing's bigger than 1 to start with, it's going to be a positive exponent. If it's less than 1, it's going to be a negative. This one, you got to move 3, 6, 7, 8. So it's 5.321, drop the zeros, times 10 to the 8th we moved it. This one here is already in a decimal form, so you're just doing that thing times 10 to the 0. It's just equal to times itself. So no need whatsoever to change the exponent. You're not changing it at all. You're not moving it. It's already got one significant number out in front, if you remember from scientific notation. Okay, so now these are write some more in scientific notation. Once again, it's bigger than 1. You're going to move it over 3, 6, 7, 8. So 5.32 times 10 to the 8th. This one here, luckily they tell you there's 14 zeros after the 9. So that's 3, 6, 9, 12. But I also have to move it by the 9, so that's really 15 spots. So it's 8.9 times 10 to the 15th spot, okay? Besides the zeros, you got to go by the 9. This one here, 24 zeros after the 4, but you also have to go by the 4. So it's going to be 3.4 times 10 to the 25th power. And that's all it is, the scientific notation. Okay. In this question here, it says use the fact that the average distance between the sun and the earth is this, 151 million, whatever, 268,468 kilometers. The average distance between the sun and that and Jupiter is this. The average distance between Pluto and the sun is this, okay? So answer the questions here, express each in scientific notation, and round the D to the nearest tenth. So we're approximating here. We're not actually doing the big thing. So sun to earth is this first one right up here. So 151,000, they want to go nearest tenth, so I'm going to move that decimal all the way back. If I take that 151,268,468, I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 spots, okay, making it smaller. Round it off, 1.5, the 1 is not going to round it up, times 10 to the 8th. That's all you're doing. So then the one with the Earth to the, let's see, Sun and Jupiter is this one right here. So that's going to be 7.8 times 10 to the what? Once again, chunks of 3, 6, 7, 8. And the distance from the Sun to Pluto is this number right here. So it's going to be 5.9. The zero is not going to round it up, so 5.9 times 10 to 3, 6, and this one's going to be times 10 to the 9th. Pluto's that much further out. We are going to use these numbers again in like a little exercise coming up, so don't lose those. Make sure you have them down. Okay, now it says in part D, how much further is Jupiter from the Sun than the Earth is the Sun? Well, the Jupiter we just did was 7.8 times 10 to the 8th. And from the Earth, it was 1.5 times 10 to the 8th. So if I want to compare the one to the other and see how much further it is, we take the difference. Now in order to take the difference, these exponents better be the same, and they are. So all I have to do on this one is take 7.8 right here, minus the 1.5, and of course I get down to 6.3 times, and they're the same thing, 10 to the 8th. So that exponent is not going to change at all. And that's my difference. Now I want you to try E. Go look up the Pluto one and compare it to the Jupiter one. And you can do the difference and subtract it. And we'll check that one in class as well as we're going along. These are different ways of using scientific notation with real application. Once again, scientific notation used for very large and very small numbers. Alright, your next exercise is also on page 8 of your notes here, is arithmetic operations. So when we add, here the key on this one to adding is you got to have the same exponent. I cannot add different exponents. It's just like saying, hey, what's 2x plus 3x squared? We can't combine them. They got to have the same exponent. But we can play and manipulate them a little bit here. So what I'm going to do is leave this one alone, 2.4 times 10 to the 20th, because it's smaller, has a smaller exponent. And I can rewrite this one here. I can knock this down to 10 to the 20th also. And if I make that one down one, okay, I'm making it smaller. I got to make this one bigger, so I move the decimal point one to the right. So that's really now 45 times 10 to the 20th. Now, it's not scientific notation officially, but it looks similar and we can deal with it. So all we have to do here now is they're both times 10 to the 20th, so it's pretty easy, times 10 to the 20th. And all I got to do is take my 45 right here and add it to 2.4. And if I add the two together, of course, we end up getting 47.4. So I'm going to add those two together and get 47.4. Remember, I added the 2.4 and the 45 that we just made. Now, is that scientific notation yet? No. I need to move that decimal back now. So the final answer, it turns out to be 4.75 times 10. Now, if I move that back, I made it smaller, didn't I? So I got to make this thing 1 bigger. I moved it 1 space, so back to 10 to the 21st power. And that's my answer there on that one. Now if I look at that's whenever you add and subtract, you got to have the same exponents here. So that is critical. These two were not the same to start with. So I played with it, made this smaller so it matches, made that bigger to counter because I was making that smaller, okay? Multiplying, whole different story. We don't need to do that. When we multiply, pretty straightforward. What's 7 times 5? 35. And then what's 10 to the negative 9th times 10 to the 5th? Well, if you remember, the rule was add the exponent. So I get 10 to the negative 4th. Now, where's my decimal right now? Right here. Is that scientific notation? No. So we have to move the decimal 1 spot here. Sorry, moving the whole thing to the left. So now it's 3.5 times 10 to the what? Well, I just made that smaller, so this thing has to be bigger. What's 1 bigger? So I move the 1 spot to negative 4 is negative 3. And that's my answer, 3.5 times 10 to the negative 3. Division's the same way. I do not have to have a common exponent here. I can divide the 12, the 1.2 right here, by 3, and I will get 0.4, don't I, when I divide that. And then when I divide 10 to the 15th by 10 to the 2nd, so it's times 10, and you subtract 15 minus 7 is 8. Is that scientific notation? No, so I got to move it back to 1 to the right here. So my answer is 4, or 4.0, times 10 to the what? Well, I just made it bigger, didn't I? So I got to make that one smaller, so 10 to the 7th. And that's my answer. That's what you have to do to counter these and add as far as multiplying and dividing. The harder ones are adding and subtracting like we did in the first one. Okay, we're pretty good overall. You should finish all the ones on the notes here, and you'll be all set then for class tomorrow. And we'll take a look at those in class, and we'll go from there practicing and answer any other questions you have on little loose ends. If you're up for it, give example 2 a try, and or the ones after this, actually, 9 and 10, and then 11, so 9, 10, and 11. All right? See ya in class.